Hey guys, I miss ya. I really do. And this whole learning thing is a little weird, but hey, we're just going to roll with it. So we're going to learn something new. I've asked you to read on Physics Classroom Lesson 4, parts A through C, and I'm going to kind of do a graph that we've already done once in class, but we're going to add to it this time. It's the what does it look like notes. You might find that in your notebook somewhere. We did it on notebook paper, and it was all just about position time graphs and what it looks like on a position time graph. But now we're going to add the velocity time graph to it. So I'm going to go through it really quickly, and hopefully it will be a good resource for you for the next few topics that we're going to talk about. Okay, so here we go. So what does it look like? I've already got mine set up here. You can see state of motion, position time, velocity time, constant velocity, at rest, speeding up, which is a form of acceleration, slowing down, which is also a form of acceleration. So we're going to draw on here what the graph looks like. So if it's going constant velocity on a position time graph, then we know that it's going to be some kind of straight diagonal line, and on some of those they might have a low slope, meaning slow, and some might have a steeper slope, which means fast. But what we know is this is a straight diagonal line. So straight diagonal line. On a velocity time graph, when we look at what constant velocity looks like, we know that we have we're starting to figure out a straight horizontal line. And so this one would be going away. This is a velocity time graph. And if we wanted to draw one where it's coming toward, it would be on the lower quadrant down here. So this one is toward. But what we know is that it is a straight horizontal line. Okay. When we have an object at rest, you guys are well aware that it doesn't matter where we place the line on our position time graph, as long as it's a straight, it can be here, it could be up here, it can be way down here, it can be in any of these places on a position time graph. But what we know is that it has to be a straight horizontal line. So this is where things start getting a little bit weird, because we have two different kinds of graphs, and a straight horizontal line means something different on a position time graph than it does on a velocity time graph. So that's why we're doing this document. If we have an object that's at rest on a velocity time graph, then the only place we can put it is at 0, right there. That's the only spot. It's got to be straight horizontal, but only at 0. So straight horizontal at 0 only. Very important, 0 only. If we have an object that's speeding up, and I'm going to refer you to Physics Classroom Lesson 3, parts A through C, which you've already read. But if an object is speeding up on a position time graph, I'm going to do two versions here, then what we have is an object that has an actual curve to it, and in that curve we can use our pencil and kind of follow along. And if we think of our pencil as the linear function, the tangent line if you will, we start off with our slope of our pencil here is quite low, and then as we move up the line, the curve of our line, we can see that our pencil gets steeper and steeper. So this object is starting off relatively low velocity and it's getting faster. Same down here, just in the negative. We have an object that's pretty close to 0, straight horizontal, and then as we move along the curve of that line, we can see that the steepness of my pencil gets steeper, which means it's getting faster. So we can have that, both of these are going away from origin, and then here is speeding up coming toward. It would look like this or this. Again, we're speeding up, coming toward. We're speeding up, coming toward. So these are going away and these are coming toward. Now when we move that over to a velocity time graph, we have straight diagonal lines. And in this case, this one is a straight, make that nice and straight diagonal line, and this one's going away, straight diagonal line, and this one's coming toward. Now this is origin over here on our position time graph, but this place here is at rest. So we can see that our object starts close to 0, which would be close to at rest, and then as it moves up, as time goes on, these would be increasing velocity. So this object at some time has a higher velocity, so this object is speeding up. If we have slowing down, we have position time graph. We'll do 2 of those. Position time graph. This one's going to be going away and this one's going to be coming toward. And if we're slowing down again, it's going to have a curve to the line. Exponential, if you will. And again, if we follow with our pencil, we see that we start off with a steep slope, and as we follow along that curve, it gets less and less and more closer to horizontal. So that means that he's slowing down. So he's starting off with a velocity and he's slowing down. Now when you hold your pencil, you want to hold it like a mustache, like this, kind of in the middle of your pencil, okay? Again, these are going away and slowing down. If we come toward and we slow down, we can see we start off steep and we get more horizontal. And these are coming toward. If we want to put that onto a velocity time graph, and we know that this is the at rest spot or 0, and we have an object that's coming, going away from origin, or away from origin, and it's slowing down, then that means he's going to start with a high velocity and come toward at rest. So this is going away. Anything on the top half of our velocity time graph is going away from origin, and anything on the bottom half of our graph is coming toward. So this is going away and it's slowing down. Remember, this is 0, so we start off with some magnitude of velocity, and as time goes on, it's losing speed and getting closer and closer to 0. So this is coming, slowing down, that's coming toward origin. So this is all going to be part of lesson 4A through C, which I do have a guided reading for and I posted for you. But this is going to be a really helpful document for you to use on the next few activities until you get used to this, okay? Let me show you my kitty cat. Kitty, those are my students and they hear about you quite a bit, and we hope that you're having a good, healthy time and you're getting out and enjoying this beautiful weather. Right, kitty? Yep, okay. See you later. Bye.